So now you know how to add fractions with like denominators. We're going to move on to subtracting fractions with like denominators. Going to be a simple lift because it's almost, well, it is identical, except for instead of adding, you subtract. But let's look at our KitKat model, because you really can't, I mean, the algorithm, well, let's just go ahead and do it. The algorithm is simple. 3 minus 2, you subtract the numerators, and the denominator stays the same. The algorithm for addition is just to add the numerators, denominator stays the same. Subtraction, basically subtract, which is what it's telling you to do. But let's show why. The confusing part is, why does that denominator stay the same? And that's why the modeling is important to establish. It's why we have you do it, so you have a visual representation of what's actually happening, so that you'll remember it. So let's first identify what 3/4 of the KitKat bar is. 1, 2, 3. That's 3 out of 4. This fourth is not available to us for some reason. It's not part of the equation or the calculation, so we could kind of just, I guess we'll just kind of blank it out so we know that it doesn't exist. And for some reason we're going to give away 2/4 of that, or that actually equals a half. Half translated into fourths is 2/4, so we're going to give away 2 pieces of that, and then we'll only have this 1 piece remaining. So that's where the 1/4 comes from. So 1 out of 4 pieces, which is why it's still described as 1 out of 4. That's still what accurately describes the piece we get. That's why the fraction bottom, the denominator, stays the same. Now let's look at another example, and you'll be ready to go. Let's do fifths this time. Let's just do a whole. Let's do 5/5, which we know should recognize as a whole, represented in fractional form. 5/5 minus, let's just do 3/5. So let's make a model. This time our model is split up into 5 different pieces, designated by that denominator. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 pieces. We start with the whole, so someone was more generous than in the last example. We start with 1, 2, 3, 4, 5 out of 5 pieces. We're going to give away 3 out of 5. So somebody else is going to get those. What do we have left? We have 1, 2 out of 5, so 2 of 5 pieces left for us. So again, the algorithm, simple. 5 minus 3 is 2. Denominator stays the same. This is why. That accurately describes what we get. We get 2 out of the 5. That's why the denominator doesn't change. A few more practice problems. We'll have you model a few. Then as it gets more complicated, you'll only have to use the algorithm. When numbers get bigger, you don't model anymore. You just use the algorithm because the modeling is no longer efficient for large numbers.